Welcome to the general chemistry section of our practice MCAT questions. In this video, we're going to be going through questions 61 to 65. So first, I'll show you guys a question so that you can pause the video and attempt them on your own. Here's question 61, 62, 63, 64, and 65. Now let's go through the questions together. In question 61, it says a new material is found which undergoes nuclear decay. It is found that the particles it emits are largely alpha particles. In a medical sense, why would it be dangerous for this material to be placed inside the human body? So there's a material which undergoes nuclear decay and it largely emits alpha particles. So why is it dangerous for this to be placed in a human body? So alpha particles, you should know they're relatively large compared to other things like gamma rays, and what they have is a high ionizing power, which means if they collide with other molecules, they can turn these into ions. So they turn them into charged species. These can go on and react with other things, and that can lead to some unintended consequences because of these reactions. But because they're large, they do not have a high penetration. So A is something which is correct, and B is not. Because B is not correct, we can remove C. And then since A is correct, we can remove D. So our correct answer is A. We don't want this to be placed inside a human body because of its high ionizing power. Like I said, it can lead to unnecessary or unwanted reactions, and then this can, start degrading cells and proteins, and it can lead to very terrible diseases inside a person. So we wouldn't want something which is releasing alpha particles inside a person and doesn't have high penetration. So in a medical sense, something like gamma rays, that's what we would use if we wanted like medical imaging, because it has high penetration. It can go beyond and past like the cells on the skin, so we can see things inside the body. But if this doesn't have high penetration and it's inside the human body, it can't really leave the human body. It's trapped within, so it's not going to go outside of the body, and then inside of the body it's going to start ionizing things. This is doubly bad, and so this is for that reason medically why we would never want something like this inside the human body. In question 62, we're asked which of the following correctly orders the following elements from least to greatest electronegativity. So we have some elements, we want to order them from least to greatest electronegativity. And for this, you need to know the trend for electronegativity in the periodic table. The one which is the most electronegative is going to be fluorine. So because of that, we can remove B and D, because only A and C show fluorine as being the most electronegative. And then if we just pull up a periodic table, such as this one right here, we can see, what do we have? Cesium, which is over here. We have lithium, we have iodine and fluorine. Fluorine right here, once again, most electronegative, iodine. So the general trend that you need to know is if we start going this way towards fluorine, that is when we're becoming more electronegative. So if you go up towards fluorine, you're becoming more electronegative. Same thing if you're going towards the right towards fluorine, you're becoming more electronegative. And the thing to keep in mind is it's much more important if you go towards the right than if you go up. So all the way over here, the thing which is the furthest, cesium, francium, like these ones are the least electronegative. Cesium actually, would be very not electronegative, so least electronegative. Lithium, since it's up, and as I said, up means more electronegative, lithium is more electronegative, so cesium is the least. So if we had our order, cesium is the least, then after that lithium comes, and then as I said, going to the right is much more important, so iodine is more electronegative than lithium. Even though lithium is higher up, iodine is more electronegative because first of all it's much closer to fluorine, and as I said, going to the right is more important than going up. So iodine comes after that, and then finally fluorine. That tells us that A is the correct answer, and C is incorrect because they switch the order of iodine and lithium. In question 63, we're asked which of the following is an example of a dimer. So which one is a dimer? A dimer means that we have two molecules or attached together which are two of the same type. So glucose is a monomer, it's one type of sugar. If we have two, that's a dimer. And maltose is correct, that's a dimer, it has two glucose molecules, so dimer specifically has two of some subunit. Starch and cellulose, those take that subunit glucose and then have it repeating again and again, and the difference in a specific way, which is how starch and cellulose differ, but they have multiple of this subunit, so they have a polymer. They're polymers instead of being dimers, which are specifically two. In question 64, we're asked which of the following is true regarding the Arrhenius equation for rate constants. So what is true about the Arrhenius equation? So this is what the Arrhenius equation looks like. So that whole fraction is the exponent for E. K is a rate, A is the Arrhenius constant, specific for whatever reaction we're talking about. E is that special number E, and then in its exponent, we have in the numerator activation energy, notice the negative charge in front of it, negative sign, and then in the denominator we have RT, or that constant, the gas constant, or energy constant, and then T being the temperature. So which is true regarding this? So for this you need to know this equation, and you need to know the relationships. Option A is saying it shows that rate is inversely proportional to temperature. No, that's incorrect. So first of all, notice that we have an exponential type of relationship. We don't have some proportional relationship that's either directly or inversely proportional. So it's not proportional, it is in an exponential type. And what we can see from this is if you ignore the A and you really just focus here on this exponent, so once again, this whole thing, this whole fraction is an exponent for this E. So overall the fraction is negative. When you have an exponent, if you have a bigger number, then you have the resulting, when you take the number and raise it to that exponent, the resulting answer is a larger number. So larger exponent, larger number at the end, and this is negative. So if we had a smaller activation energy, if the activation energy went down, then we have a less negative number, right? So it's still a larger number now, less negative, closer to zero, larger number. So lower activation energy is going to overall make a big number for whatever E calculates to, and then ultimately that translates to K. So if we have a lower activation energy, that's telling us that K is higher. So lower activation energy increases the rate of reaction, and similarly a higher T. R does not change, but T can. A higher T gives us once again a small number, because if we have a big denominator, we have a small number. Overall, we have a number that's closer to zero for the exponent, and so either increasing the temperature or decreasing the activation energy gives us a higher rate for the reaction. That's what the Arrhenius equation tells us. So A was incorrect. B is saying increasing temperature raises the number of collisions which result in a reaction. So B is correct. It's telling us increasing temperature raises the rate of the reaction. Option A was saying that rate is inversely proportional to temperature. That's implying that you increase temperature, the rate goes down. That doesn't logically make sense if you think about it, and then especially with the Arrhenius equation, it doesn't make sense. Option C is saying rate is proportional to activation energy. No, it's kind of like an exponential relationship, and also it's not direct. Activation energy should go down for rate to go up. And finally, D is saying activation energy is not a component of the equation. That's incorrect. If you know the equation, you know that it is. So B is the correct answer. In question 65, it says an experiment takes place on a planet which contains entirely different elements from Earth. The researcher constructs a new periodic table, and the researcher examines several atoms and hopes to qualitatively describe their sizes based on atomic radius. Of the following, for which position on the extraterrestrial periodic table would the largest element be found? For this, you need to know the trend for atomic radii. So essentially, we just know that we are constructing a new periodic table, and it's based on, their size is based on atomic radius. Where is the largest element? For this, you need to know if you go down and then you go to the left, this is a trend for increasing atomic radius. So whatever is most to the left and then most low, most down in the periodic table, low in a group, that is going to be the one with the biggest atomic radius, and so the largest size element. So let's look at the groups first. Option B and D are showing group 9, so we can remove these because it's too much to the right, whereas we want something on the left. So we're looking between A and C, and then between A and C, C is lower, right? As I said, lower is increasing. Group period 4 is lower than period 2. So if something was in group 3 and in period 4, it's all the way relatively to the others. It's more so in the bottom left position, and this is where you have an increasing atomic radius. That's it for the questions in this video. If you enjoyed what you saw, make sure to check out our course. The link is right here. And in that course, we have some things like a customized study schedule as well as lecture videos from medical students. For everything else, check out the course in the link, and don't hesitate to reach out to 30daymcat@gmail.com if you have any questions. Here are some reviews for our course, as well as our Instagram page. Make sure to follow us there because we have free content just like we have here on the YouTube page. And that's it for this video. I will see you guys in the next one.